The fourth experiment is a Schmidt trigger. Required component is IC741. This is the IC741, which is having 8-pin IC. You should place it in a chip socket. So now pin number 1, 2, 3, 4, 5, 6, 7, 8. Okay, the other component is a 10 kilo ohm resistor, 19 kilo ohm resistor, DC regulated power supply, then signal generator, then CRO. Okay, the circuit design. Just show me the first design. So here they have given UTP expression. UTP is defined by R1 divided by R1 plus R2 into Vsat plus R2 divided by R1 plus R2 into V reference. And LTP is defined by R2 divided by R1 plus R2 into V reference minus R1 divided by R1 plus R2 into Vsat. So V saturation is equal to 90% of VCC. First, you just sum both UTP and LTP. You will get this expression 2R2 divided by R1 plus R2 into V reference. Then subtract UTP minus LTP. You will get this expression. Let us say equation 2, and this is equation 1. Okay. Now the given values is LTP and UTP. And you must design, examiner may give for instead of 2 volts any other volts, instead of 4 volts any other volts, and V saturation you must calculate it. VCC is always 12 volts. For 12 volts you should calculate Vsat. Approximately you will get 10 volts. So now by using second equation 2, so you put the given voltage is here 4 volts and 2 volts. The given voltage is here 4 volts and 2 volts. So substitute in equation 2. You will get a expression R1 equal to 9 times of R2. R1 is equal to 9 times of R2. Then take R2 is equal to 10 kilo ohm. Then R1 become 90 kilo ohm. Then take equation 1. UTP plus LTP is equal to 2 into R2 divided by R1 plus R2 into V reference. So we need to calculate V reference over here. We got R1 value and R2 value. Then substitute all those values. Just calculate V reference value. Okay. The circuit diagram. So this is the op amp. So pin number 7 always should be connected to positive power supply and a fixed power supply. And pin number 4 is negative power supply, in the sense black terminal. This is a red terminal, and the green should connected to ground. And pin number 2 is a inverting terminal connected to input signal. So input signal specification is Vin is equal to 10 volts and frequency is equal to 1 kilohertz. And pin number 3 is a non-inverting terminal. Is for that terminal 10 kilo ohm resistor is connected. R2 is a 10 kilo ohm resistor is connected. The other end of the R2 is connected to V reference, variable power supply. Then the negative terminal is connected to ground. Again, in between pin number 2 and 6, we need to connect 90 kilo ohm, that is R1. Okay. And pin number 6 you will get a output, and pin number 2 will get a input. The input is sinusoidal waveform. And output is square waveform. So the circuit will convert sinusoidal waveform to square waveform. So the magnitude of output voltage minus Vsat and plus Vsat. Okay. When the negative waveform start from positive region to negative region, there is a crossover. So this is LTP, 2 volts. Again, from negative to positive, there is a crossover here. This is UTP. Circuit figure. The circuit connections like this: pin number 1, 2, 3, 4, 5, 6, 7, 8. Now, so for pin number 2, signal generator. So pin number 2, CRO Pro. So this pin number, this should be connected to pin number 2. The other terminal is connected to ground, in the sense common point. We have already connected here. And pin number 3 is a 10 kilo ohm resistor. Again, pin number 3, 10 kilo ohm resistor. The other end is connected to variable power supply, red terminal. The black terminal is connected to common point over here. Then again pin number 3 and 6 we need to connect 90 kilo ohm. This is the pin number 3, this is the pin number 6. So across these two terminals we should connect 90 kilo ohm. This is a R1 value. R1 value. Then we need to connect a DC power supply, fixed power supply to operational amplifier. So from the red terminal, pin number 7, from the black terminal, pin number 4. Okay, and from the green terminal, common point. So this is keep it in mind. Okay. Now for the input signal to the channel 1. Input signal to the channel 1. So where you have connected for input signal, there only you connect channel 1 terminal. You connect it properly. And block always ground. And use the channel 2 output terminal, pin number 6, and common point is ground. Now switch on the power supply, switch on the main, switch on the power supply, okay, and switch on a CRO, and switch on variable power supply also, and keep V reference is equal to 3.3 because we have calculated here 3.3. So adjust 3.3, okay, 3.3. Before that we need to set input signal. So if you leave this button, it shows the frequency, and vary coarse and fine. Select a range 2 kHz and vary coarse and fine and adjust 1 kHz, and push this button, it shows the peak to peak voltage. Using level 5, adjust 10 volts, okay. Then switch on CRO, and open all the buttons, and you can't see the signals now. Now if you want to see the channel 1, so open this one and adjust the channel 1, so until you get proper sinusoidal waveform, and put it in other channel 2, even that also adjust it to get proper waveform. This is square waveform. Now keep it in both. So before that, keep it in dual mode. CRO should be in a dual mode. Keep both channel in ground initially and merge it in the center of the CRO, in the sense ground position properly, and open the ground, and output should be in DC mode, and increase your time scale. This is our output waveform. Now check it out. When positive cycle is intersection over here, this is LTP, and negative, it will start from negative region to positive region. This is another intersection. This is UTP. Okay. So LTP, use a exposition in a CRO. And bring this waveform to somewhere else to here to get a reading, proper reading. So this is 0.1, 0.2, 0.4 into 5. 0.4 into 5, 2 volts. So LTP. And the same way from this one, negative region to positive region, there is a crossover here. Using exposition, take this over here and check it out from ground level. From here to here, 0.8, 0.2, 0.4, 0.6, 0.8, 0.8 into 5, 4 volts. So this is your UTP point. So what we have designed, LTP value, the same thing is getting, and UTP value also same thing we are getting practically. And put it in XY mode to get a hysteresis curve. Put it in XY mode and open dual. So we will get such kind of waveform, and keep it in again ground, both the channel, and use a Y position or X position. Get that dot into center of the CRO. Then open this ground and interchange your cable, CRO probes. So this is your, and now this is the output. Keep it in DC. So this is your transfer characteristics. transfer characteristics. So the first line is approximately above first subdivision. So that is equal to 0.4 into 5, 2 volts. The other one is 0.8 into 5 volts. 0.8 into 5 equal to 4 volts. So this is our hysteresis input-output characteristics. So this is a input LTP and this is a UTP. LTP and UTP.